Um, for those of you using your own like coding place, just make a new file. And for those using this VS Code thing you just downloaded, um, there are these steps. So first, go into your wherever you put files, and then create a folder. And then you open the folder by clicking the red circle thingy, that button, open folder. And then you click on the buttons that are circled and type the thing. Next. See, I don't trust you people, so time to test. Okay, go to your file and then type the thing in the box. Just copy that exactly, and then click the green thingamajig. Yeah, and then observe a thing should magically appear on the bottom, and it should have like something similar to what's circled. Okay, does everyone's work? Does hello world magically appear on the bottom? Okay, yes. Okay, cool. Um, witchcraft. No, it's just normal magic, not witchcraft. Okay, remember the place where hello world magically appeared? Yeah, that's the this place, terminal. And then just type exactly what's in the folder on the right. Type exactly pip and install and this auto GUI stuff. It should like magically generate a lot of interesting text. You'll feel like a professional programmer. And the goal here is successfully installed Pi Alto GUI. So that was the boring stuff. This is how to think. It's a way of thinking to do stuff, and it's not brainwashing. Okay, this is the most important slide in this deck. It like represents the mentality of how to automate any task, basically. Yes, Sun Tzu. Yes, by Sun Tzu. You need to break every action into its most basic parts. See, like, well, hey, that's cool, right? It's by this Sun Tzu guy, but like, what does it actually mean? Because famous people tend to say stuff that are very confusing. So, think of a simple task. You're trying to close a window. It usually involves the X shape, and if you're telling someone like a human like me to close the window, you just tell me to like find the X and click it. Maybe say something like top right or top left. But it's a computer. Think of computer like annoying old people who don't know how to use computer, and they're like, what X? What do you mean click the X? Like what do you mean by top right? So you need to give really specific instructions, like like find exactly where the X is. Tell them to move their mouse there, and then click. My chat keeps disappearing. Wait up. Oh yes, annoying old people, like the person here. So instead of giving big commands and expecting the computer or old people to understand, you need to give tiny, really precise commands that cannot be like wrongly executed. So this is where code starts to like appear in the slides, like actually. And this is the basic commands. Remember the basic parts from the last few slides? Well, this is the basic parts you need to create your automation program. And if you, for like some reason, wasn't able to get the code stuffs working, this is simple instructions to the computer. And even if you're not able to follow along, which I'm like really sorry, I can't help much, but even if you can like think along, that's still very help. Yes, basic stuff. Right. So if you are like coding stuff, delete the hello world thing and put import pi auto GUI in line 1, so to the right of the 1, and put import time to the right of the 2, right below import pi auto GUI. So this pi auto GUI thing is a cool stuff that lets you automate stuff. And time, like you're like creating time. Just kidding. It's to delay stuff. So if you force the computer to do something, you then force it to wait a bit before doing something else. So hopefully you've typed these 4 words. So next slide. So this is a general overview. Don't copy anything yet. To force the computer to do something, like click somewhere, you need to know where that is. Like if a friend just randomly asks you where a pizza place is, you can't like tell them because you don't know which pizza place they're talking about. So you need to find the location, you need to find the target before you can do something with that target. So first I need to teach you the art of window flipping, which is the art of playing video games when you're not supposed to. So for the Windows users out there, use Alt Tab, and for the Mac users, you use Command Tab. And the way this works is you hold the Alt or Command key. What is this? You hold the Alt or Command key, and then you tap the tab until the highlighted portion, a highlighted window, is the window you want. So if you want to flip between like your VS Code and Zoom, you Alt Tab, you hold Alt and you click Tab until Zoom is highlighted. Then you hold Alt and click Tab until you're on VS Code. And then afterwards, you just need to tap Alt Tab, and then it'll just alternate between the two. Okay, second part of finding coordinates is how coordinates work. So you have your cursor. It's like pretty big, and the point that actually does the clicking is the tip of the arrow, which is circled in red, or the tip of the index finger. This will help with like some more precise clicking maneuvers, like trying to find the Mac window close button. And another thing is the screen coordinates. Like you remember the first quadrant in math class. Yeah, forget about that for now because math class is slightly useless. So in computer, 0, 0 is at the top left. As you can see from this interesting image I stole off of the documentation. Look, so if you go right, the x coordinate increases, which should be fine. But then you go down and the y increases. So the highest coordinates is on the bottom right, and the lowest is on the upper left. Yes, cool visual. Now, with all this, you can find the mouse position. So first you like take the code, and then you type exactly that. So time dot sleep. That makes it like just sleep and do nothing. And the number inside is how many seconds it sleeps and does nothing. So if you put a 1 in there, it sleeps and does nothing for 1 second. If you put a larger number in there, like 2, it sleeps and does nothing for 2 seconds. And that is up to you. That number should be how many seconds it takes for you to window flip plus 1. So I window flip fast, so I only need 1 second of delay. Now the second line is very important. It's the actually useful line. this pi auto GUI dot position is the position of your cursor when that line gets called. Like you tell the computer to find the position and then you print it out so you can actually see it. So this is how you find the position. You first go to VS Code, you click the green thingamajig, and then the code starts running. During that 1 second or 2 second time where the program sleeps and does nothing, you window flip to the program that you want to automate, and then put your mouse cursor on a position you want to find out. And then you window flip back to VS Code, and you see where hello world was. That box, you'll see something like point x equals something, y equals something, and you just use like this coordinates and some common sense to figure out if it's right. Like if you put your mouse on the upper left of your screen and you got some really big numbers, you know something's wrong and you should do it again. So for an exercise, just copy that code in the top left box, click the green thing, and then immediately hover your mouse over the Chrome logo on the bottom or your Safari logo. And then you will know the exact coordinates of your logo. And this information is useful because then you can like move your mouse there and click on it. So the rest of these are very easy, and it's just really simple commands where you just tell the computer to do something. Like, oh, if you want to move the mouse to someplace, you use the move to command. Like you move your mouse to, and then you put your coordinates in there. And where do you get these coordinates, you ask? Well, you find them using, finding mouse position. And then the image on the right, you can see it's similar, but also different. Instead of move to, you just have move. And move to is you set a location and you move your mouse there. Move, on the other hand, your mouse is at some location right now, and you move it this much right and this much down. So move is relative to your current mouse position, and move to is absolute. You can experiment by putting random values in there. Okay, so now what do you do with your mouse besides moving it? Well, you click it, you click the mouse, sometimes really fast, like in Minecraft. And you know, there is a click function, but remember that we need to find the most basic steps. And the most basic functions of the mouse button is to push the mouse button down and you get the mouse button up again. And well, there's commands for that. Mouse down simulates you push the button down, and mouse up means the button gets pushed up. So if you want a click, like just a normal click, left click, right click, you just first mouse down and then immediately after that, you mouse up. Because that's what a click actually is. You push the button down and you quickly remove your finger from the button and it goes up. Mouse button goes down, mouse button goes up. That's a click. And button equals, that's what button you want to click. Now, so after that, if you combine moving the mouse with button down, and mouse up, now you can have a drag, where you first mouse down on something, then you move the mouse somewhere, and then you mouse up. That's basically what a drag is. You click down something and you hold it there, you move it, and you release it. Okay, the last thing that you can do with your mouse is to use the interesting scroll wheel. And scrolling is easy. I will, like scrolling, I wonder what the command is. Oh, it's pyauto.gui.scroll. And the number in there is how many clicks up you want. And like, what is a click? So sometimes when you scroll something, the scrolling isn't like continuous. You scroll something on your mouse wheel and it goes like up downwards. That's a click. But usually, what I do is I don't worry too much about it. I don't worry too much about it, and I simply just do some testing. Like I test what number I plop in there to make the program work properly. You can try scrolling right in your VS Code, and yeah, you can try it. You should just move the text up and down. Hey, the other thing that you use on a computer is the keyboard. And similarly with mouse down and mouse up, you have key down and key up. And key down, basically, you press it down, and key up means you release the key. And inside the parentheses and those little quotation marks, and you do need the quotation marks, you put whatever button on your keyboard that you want to press down. This could be a letter, a number, a symbol, even a special button like the Windows key or the Control key, or like Command. And when you combine key down and key up, you get a press, just a normal, you type an A on there, you press an A. Now if you chain together many presses, now you get writing. Now this is special because you can't put any special characters in the right. It's just simple English typing. This is useful to say, like, if you want to steal some stuff off of the internet and automatically paste it onto your homework. And finally, there's hotkey. This is another more advanced function where you basically hold down the first button, and then you press the second button, and then you release the first button. So remember the window flipping? You can have a program automatically window flip for you for more Pog stuff of part 2, because part 2 is where you get to think and use brain. Okay, so you need to build a cool stuff, and here are the steps. First of all, to automate anything, you need to know how to do it yourself. Because if you don't do it yourself, you don't know the steps to automate. And then you have to think, and then you have to think again. And after you perfected your thinking, you do stuff. Okay, so for this cool project, we're going to create a program that opens the calculator app and then does 9 plus 10. It's really simple, but it's something that every computer and operating system is like, it comes with the calculator. Okay, so the first step is to do it yourself first. Just whatever your method may be, open the calculator on whatever computer you're using and solve 9 plus 10. Step 2, use brain. So I'll assume you've opened the calculator and did 9 plus 10. Now think of the steps you took. Did you click on the calculator? Did you instead use, did you click on the numbers 9 and then the plus sign and then 10? Or did you use the keyboard to type in 9 plus 10? Now think of the efficiency of those steps. Like, I could open the calculator 50 times, close 49 of them, and then do 9 plus 10, but that's not very efficient. And you need to think that you are going to automate this process. So tasks that might be easy for humans are sometimes really hard for computers. Finally, a thing I learned while automating and botting my games is that usually if there is a typing option available, it is usually better, easier, and less prone to failure than an option where you find the coordinates and click on it. So think of how you inputted 9 plus 10 into the calculator, and think before that. Think of how you opened the calculator. And maybe think about your life choices while you're at it. So, after analyzing what you did when you opened the calculator, you can get steps. You can, like, for example, I like to click the Windows key. Yeah, yes, 7 memes. The most important part of any presentation, really, memes. So the thing on the right, it's my way of doing 9 plus 10. And you can see by the presses and writes that my strategy is to first click the Windows key, then type in CALC, press enter, and then use my keyboard and type in 9 plus 10 instead of using my mouse and clicking 9 plus 10. Finally, I use my enter key to get the result. You might also notice that the program is sleeping a lot. It sleeps more than I do, right? So the time.sleep 0.5 is to give the program time, give your computer time actually to execute the instruction. Like if you press the Windows key on a Windows computer, it doesn't immediately pop up on the first frame. You need to wait a small amount of time. I like to do 0.5 seconds because it seems to work. However, you will notice that there is one time.sleep 1 second in the middle. That's where I launched the calculator. Calculator is a really small app, so it doesn't take too long to launch, but I found that using 0.5 seconds is still too short. So you need to remember that launching apps takes significantly longer than some of the other things you do, like clicking a button. So you need to give it adequate time to fully load before you put the next set of instructions in. Now, I would like to remind you that these are my steps. No matter what way you open the calculator and did 9 plus 10, whether you opened 50 of them and closed 49 of them, or you did 99999 and you deleted a lot of the nines until you have 1. No matter what you did with your mouse and your keyboard, you can imitate exactly that. Min. Bye, Min. Thanks for coming. I wait, so no matter what steps you took to open the calculator and do this task, you can make the computer do exactly the same steps using these simple commands. And the result you should have gotten is that 9 plus 10 equals 21. However, if something went wrong and you got 19 instead, that's fine. That's also fine. Now, you've probably seen this slide before, and it's here again. That's because it's important. The calculator example is pretty lame, but it demonstrates that if you break what you do, your action, into its most basic parts, you click that button and break it down into move the mouse there, mouse down, and mouse up. You can create a script that does any action you do on the keyboard or mouse for you. Now, as I said, the calculator example, it's lame. I only picked that because if I did something interesting like a game, it's more things for people to install, and that's more chaos, especially for virtual lectures. But here are some of the possibilities that you can do. Of course, the first I think of is gaming because they're fun. On the left, it's a sniper, and if you add in some of image recognition algorithms, you can find that red outline and then headshot people every single time. Or you can do a role-playing game where you have to do quests, but then repeatedly do quests. But instead of you doing them, you make a script do them for you. Now, what if you connect automation, but instead of automating your mouse or keyboard using the basics I taught today, instead you use a robot, you use hardware, you use the same mindset of breaking actions into small pieces, but instead you feed the instructions to a robot. And then you have modern manufacturing. That's what modern manufacturing is. Robots building stuff, usually. Now, if you add in machine learning, fancy algorithms, then you reach the pinnacle of meme robots, like the one on the left. Or you can build a robot that does your homework for you. I'm lazy and I don't want to handwrite all my school homework, so I thought of a way to make a robot write it for me. But I don't have the money to build it yet, which is depressing. These examples show you the possibilities. It's not just a stupid skill just to 9 plus 10 on the calculator. It's something that can be applied to other fields. Oh look, it's this slide again. I wonder why it's here. Okay, so this is finished. It's an interesting ending slide. Yes, very pog. Now you can ask random questions. There's some cool stuff, laugh out together stuff. You should join the Discord and Instagram. I don't know what verb you use for Instagram, but just do it. And then there's this form you're supposed to fill out, and it will be in the chat. Chat is pog. Yes, this form, which Lot sent me to send you so you can tell me how bad I did. Yay, thank you, Amanda.